Most people think they know Uluru. They have seen the photographs. They know it is large, red, and somewhere in the middle of Australia. What almost nobody knows is that the rock sitting above the desert surface is a tiny fraction of what is actually there. Beneath the ground, extending in ways that took geologists decades to properly measure, is a structure so vast and so geologically strange that scientists who study it professionally still reach for unusual words when they try to describe it. The deeper they look, the more complicated it gets. The rock that is not a rock. Here is the first thing to understand about Uluru, and it is the kind of fact that sounds simple until you actually sit with it. What you're looking at when you see Uluru is not a boulder, it is not a hill, it is not, technically speaking, even a mountain in any conventional sense. What you are looking at is the exposed tip of an enormous underground rock body that extends deep into the earth in ways that the eye standing at the surface gives you absolutely no way to appreciate. Geologists classify Uluru as an Inselberg, from the German for island mountain, a term used for isolated rock formations that rise sharply from a surrounding flat plain. But that classification, accurate as it is, still undersells the strangeness of the thing it is describing, because the surface expression of Uluru, the part that appears in every photograph, the part that catches the light at sunset and turns that particular shade of deep red that people fly thousands of kilometers to see, represents only a fraction of the total rock body sitting beneath it. The formation you can see stands 348 meters above the surrounding plain. That is already a considerable height. The base circumference at the surface runs to approximately 9.4 kilometers. These are the numbers that appear in every brochure and on every park information board, and they are accurate as far as they go. They do not go very far. What most of those information boards do not mention is that the rock does not simply stop at ground level. The same acoustic sandstone formation continues downward well below the desert floor, extending into the earth in a near vertical orientation that geologists have spent considerable effort trying to fully map. Early estimates suggested the underground portion extended perhaps 2.5 kilometers below the surface. More recent assessments, drawing on improved geophysical survey techniques, have pushed that figure higher still. There is also a detail about the rock's orientation that genuinely surprises most people when they hear it for the first time. The layers of rock that make up Uluru, clearly visible as parallel lines running across its surface, are not horizontal the way you might expect sedimentary rock layers to sit. They are nearly vertical, tilted to approximately 85 degrees from horizontal. The rock was not deposited the way it now stands. It was folded, compressed, and rotated by tectonic forces over hundreds of millions of years until it ended up pointing almost straight up rather than lying flat the way it originally formed. What you are looking at when you look at Uluru, in other words, is a structure that has been through more geological violence than its smooth, serene surface would ever suggest. The underground revelation. For most of the 20th century, what sat beneath Uluru was essentially a matter of educated guesswork. You could map the surface with considerable precision. You could measure the height, trace the base perimeter, describe the rock layers visible on the face, what was happening underground, how deep the formation went, what shape it took below the desert floor, remained largely inference. Geology conducted from the outside looking in, that began to change as geophysical survey technology improved in the latter decades of the 20th century. Gravity surveys, seismic reflection studies, electromagnetic imaging techniques, methods that could probe the subsurface without driving a single drill into the ground, started giving geologists something they had never previously had at this site, an actual picture of what was down there. And the picture that emerged was not the one anyone had been quietly assuming. Uluru sits within a broader geological region called the Amadeus Basin, and the Amadeus Basin turns out to be considerably more structurally complex than surface mapping alone had managed to convey. The rock body that becomes Uluru at the surface is part of a larger formation called the Mutijulu Arkos, a thick sequence of sedimentary rock that was buried, compressed, and catastrophically deformed during a mountain building event geologists call the Petermann orogeny, which occurred somewhere between 500 and 550 million years ago. During that event, the sedimentary layers that would eventually become Uluru were folded under pressure so extreme that they rotated from their original horizontal orientation to the near vertical position they now hold. The 85-degree tilt visible in the parallel lines running across Uluru's surface is not how the rock was deposited, it is what happened to it afterward. The mountain range produced by the Petermann orogeny was, by current estimates, comparable in scale to the Himalayas, which is a sentence worth reading twice. A Himalaya scale mountain range sitting across the centre of the Australian continent, gone. Eroded to almost nothing across hundreds of millions of years of geological time. Uluru and Karajuta, 25 kilometres to the west, are among the very few surface remnants of that entire mountain chain still visible today. Everything that once towered above them has been worn down to flat red dirt, now Karajuta. Since it keeps appearing in the same photographs and on the same tour itineraries as Uluru, it is worth being clear about something the brochures consistently fail to mention. Karajuta is made of an entirely different rock, a conglomerate called Mount Currie conglomerate, formed from different source material under different conditions, producing a visually and geologically distinct formation that happens to sit within sight of Uluru. The two formations are not related expressions of the same body. They did not form together. They are, in the most geologically precise sense available, strangers. They ended up neighbours through the same tectonic violence, not through any shared origin. They photograph beautifully together. Geologically speaking, they have almost nothing in common. The surveys that revealed all of this did not simplify the picture of what sits beneath Uluru. They made it considerably more complicated, which for a rock this old seems entirely appropriate. How old is old? 500 to 600 million years old. That is the range most commonly cited for the sediments that became Uluru, referring to when the original sand and grit were deposited in an ancient river delta system before they were buried, compressed, and transformed into the hard acoustic sandstone now visible at the surface. To give that number some context, because it is the kind of figure that tends to slide off the brain without a reference point, 550 million years ago, the first complex multicellular animals were only just beginning to appear in the world's oceans. There were no plants on land, there were no insects, there were no vertebrates of any description. The closest thing to a complicated organism on the Earth's surface at that point was a collection of microbial mats and early soft-bodied creatures, leaving their traces in shallow marine sediments. The sand that would eventually become Uluru was being deposited into a river system during a period of Earth history so remote that the evolution of every land animal that has ever existed had not yet begun. And here is the part that tends to produce a particular kind of silence when you say it out loud. The dating of Uluru's formation is not a fixed number. It is a range that has been progressively revised as dating techniques have improved and as researchers have applied newer methods to samples taken from the formation and from equivalent rocks in the broader Amadeus Basin. Each revision has not made the rock younger. It has either held the estimate steady or pushed it older. Geochronological work published in the late 1990s and refined through the 2000s using uranium-lead dating on zircon crystals recovered from the Mutijulu. Arcos helped establish the depositional age of the sediments with greater precision than had previously been possible. The same methods also helped constrain when the deformation event that tilted the rock into its current orientation actually occurred. What that research confirmed is that the rock's history involves at least two distinct major phases: the original deposition of sediment and the subsequent compression and folding during the Petermann orogeny, separated by a meaningful span of geological time. The rock you are looking at did not form in a single event. It accumulated, was buried, was cooked under pressure, was tilted, and was then gradually exhumed over hundreds of millions of years as everything above it wore away. The surface you can walk up to and touch today has been sitting exposed at or near the surface for somewhere between 300 and 500 million years. It is not fresh geology. It is some of the most ancient exposed rock in a continent already famous for its ancient exposed rock. The water world below. Here is something that sounds like it should not be true, and yet the hydrological research backs it up completely. Uluru, sitting in the dead center of one of the driest inhabited regions on the planet, is a water harvesting machine. A sophisticated, geometry-driven, extraordinarily efficient water harvesting machine that has been operating continuously for hundreds of millions of years without a single moving part. Here is how it works. The rock's surface, all 9.4 kilometers of that base perimeter, is not flat. It is curved, ridged, and shaped in ways that shed rainfall with remarkable precision, channeling runoff into a series of natural drainage lines that direct water toward specific points around the base. The water holes that form there are not accidents of the landscape. They are the output of the rock's own geometry, concentrating and preserving water in an environment where, without the rock doing exactly this, there would essentially be none. Those water holes persist long after the surrounding desert has baked dry following a rainfall event. Weeks after the red dirt around them has returned to dust, water is still sitting at the base of Uluru in a desert because a 500 million year old piece of sandstone has been quietly solving the water problem the whole time. That part was figured out relatively early. What took considerably longer to establish is what happens inside the rock itself, because despite being extraordinarily dense and hard at the surface, the Mutitjulu Arkose is not entirely impermeable. Water enters through fractures, joints, and permeable zones in the rock and moves through the subsurface along pathways that hydrological research is still in the process of fully mapping. The sandstone that looks from the outside like a single solid mass is internally a slow-moving water transport system whose full extent researchers have not yet completely traced. The broader regional aquifer system that Uluru's subsurface connects into has been the subject of ongoing hydrogeological study for practical as much as scientific reasons. Understanding how water moves through this landscape matters directly for land management decisions across one of the most visited national parks in the country, and here is the part that should stop you for a moment. The Anangu people, whose continuous relationship with this landscape spans somewhere between 50 and 60,000 years, have always known where the water is. Every significant waterhole around the base of Uluru appears in Chukupa, the living body of Anangu law and knowledge, with its own name, its own story, and its own set of obligations attached to it, not as a general observation that water pools at the base of a rock after rain. As specific named storied locations with precise cultural significance attached to each one. The hydrological research being conducted today is, in the most direct sense possible, producing a scientific diagram of something the Anangu have been carrying in memory for 50,000 years. The instruments are catching up, slowly. Anangu knew first. The Anangu people are the traditional owners of Uluru Kata Juta. Their continuous connection to this landscape is estimated at somewhere between 50,000 and 60,000 years, a figure that makes them among the longest, continuously documented human communities in relationship with a specific place anywhere on Earth. That is worth stopping on for a moment because figures that large tend to become abstract before they become meaningful. 60,000 years ago, modern humans had only recently left Africa. The earliest anatomically modern human remains found in Europe date to around 45,000 years ago. The cave paintings at Lascaux in France, often held up as one of the oldest examples of complex human symbolic thought, were made approximately 17,000 years ago. The Anangu were already living at Uluru, already maintaining their relationship with this landscape for tens of thousands of years before any of that happened. The Anangu do not describe Uluru through the framework of geological science. They describe it through Jukurpa, which is sometimes translated as the dreaming, but which inadequately rendered in that phrase, since Jukurpa is not simply a collection of ancient stories. It is a living, legal, and spiritual framework that governs the relationship between people and country, encodes ecological and practical knowledge about the landscape, and describes the actions of ancestral beings whose movements and conflicts shape the physical features of the world that now exists. Specific features of Uluru's surface, caves, waterholes, cracks, stained streaks running down the rock's face, are all explained within Jukurpa through the actions of specific ancestral beings. The Mala, a group of rufous hair wallabies, are described as arriving at Uluru from the north and establishing their camps there. The Kunia, a Wama python, is described as fighting the Liru, poisonous snakes, at the rock's base. The specific locations where these events are said to have occurred correspond to particular physical features at the surface that you can stand in front of and look at today. This is the part that researchers studying the intersection of traditional ecological knowledge and formal scientific method have found increasingly significant. The Jukurpa is not simply a spiritual framework operating separately from empirical knowledge of the landscape. It encodes specific, verifiable information about the landscape, about where water can be found, which plants can be eaten, which animals move through at which times of year, how the rock behaves in different weather conditions, information gathered and tested and refined across an unbroken span of time that makes any formal scientific study of the site look like a brief introductory glance. The Anangu did not need a geophysical survey to know the shape of the water system around the rock. They did not need a hydrogeologist to tell them which drainage lines led to persistent water and which dried up quickly after rain. They did not need an acoustic researcher to notice that the rock makes sounds in particular conditions. They knew. They have always known. They simply encoded that knowledge in a framework that the scientific tradition spent a long time dismissing before it slowly started paying genuine attention. The acoustic secret. In 2014, researchers conducting acoustic studies at Uluru documented something that, depending on your starting assumptions about what a large piece of sandstone is capable of, sits somewhere between genuinely interesting and genuinely remarkable. Uluru sings. Not metaphorically, not in any supernatural sense that requires abandoning a scientific framework, but the rock produces sounds, low resonant frequencies generated by specific physical mechanisms within the formation itself that have been recorded and measured, and that researchers have described fairly carefully and in the scientific language appropriate to peer-reviewed research as unexpected in their character. The primary driver of the acoustic phenomenon is thermal expansion and contraction. During the day, the surface of Uluru absorbs an enormous amount of solar radiation. The rock heats unevenly depending on aspect, surface texture, and shadow patterns cast by the formation's curves. As it heats, it expands. As it cools rapidly in the evening when the desert air temperature drops sharply after sunset, it contracts. The expansion and contraction of rock at that scale, across a surface area of that size, produces sounds. This is not unique to Uluru. Many large rock formations produce thermal cracking sounds that can be heard at the surface. What made the acoustic research at Uluru interesting was the specific frequency range of some of the sounds recorded, and the way the rock's geometry appeared to amplify and direct certain frequencies in ways that produced at specific listening positions around the base a quality of sound that the researchers described as difficult to attribute entirely to simple thermal mechanics. Infrasound frequencies below the threshold of human hearing was also detected. Infrasound produced by large geological formations is a documented phenomenon, and it is of particular interest to researchers because infrasound at certain frequencies produces physiological effects in humans, including a general sense of unease or the feeling of a presence nearby without any identifiable visible cause. This has been proposed as a partial explanation for the sense of heightened awareness that many visitors describe when they are standing at the base of Uluru. The Anangu have always described Uluru as alive. That description has been treated by the outside world for most of the 20th century as spiritual language to be appreciated in its cultural context, but not taken as a literal empirical claim. The acoustic research does not prove the Anangu cosmology correct in any straightforward scientific sense, but it does confirm that the rock is doing things physically that the human nervous system is capable of detecting, even when the conscious mind cannot identify a specific source. The rock produces frequencies. Some of those frequencies have measurable effects on the people near it. The Anangu noticed this, encoded it in their understanding of the place, and described it in the language available to them. And frankly, that seems like the most reasonable response to a piece of geology that hums at you, what the climbing ban actually protected. In October 2019, the climbing closure at Uluru took effect. After decades of a controversy, after decades of the Anangu asking visitors clearly and consistently to please not do this thing, and after decades of visitors doing it anyway, the climb was officially closed. The public conversation around the closure was dominated, understandably, by the cultural argument, and the cultural argument is straightforward and serious. The climbing route crosses a path of deep significance within Chukurpa, connected specifically to the Mala, the rufous hair wallaby ancestral beings whose story sits at the center of Anang identity and lore. Climbing the rock was not in the Anangu framework equivalent to hiking up a large hill. It was closer to walking across an altar during an active ceremony. The Anangu said this clearly, repeatedly, and for a very long time. Many visitors climbed anyway because the legal framework governing the site for most of that period did not give the Anangu the authority to enforce what they were asking. They could request, they could not prohibit. That changed in 2019. Good. Moving on. What got considerably less coverage in the reporting around the closure was a second, entirely separate body of reasons why researchers had been quietly regarding the climbing track as a problem well before the cultural debate reached its conclusion. Uluru's surface is not bare rock. It is covered across most of its extent by a biological crust, a living community of cyanobacteria, algae, mosses, and lichens that has colonized the sandstone surface and is doing considerably more than simply sitting there looking interesting. This crust stabilizes the rock surface against erosion. It influences the way water runs off during rainfall events, directing flow in ways that feed the water holes at the base. It contributes to the soil-forming processes that support the plant communities growing around the rock's margins. It is, in the driest possible scientific language, ecologically functional. In slightly less dry language, it is the rock's skin, and it is alive. Decades of foot traffic along the climbing route had been stripping this crust from the sandstone surface along the path and in the surrounding area. Climbing boots do not distinguish between bare rock and a slow-growing biological community that has taken years to establish itself under conditions of extreme heat, UV exposure, and minimal moisture. The degradation along the climbing route was measurable. Researchers monitoring the site's ecological condition had been documenting it for years before the closure. Biological crust recovery in Central Australian conditions is not a fast process. This is not an ecosystem that bounces back over a single wet season. The direction of change along the former climbing route since 2019 has been consistently toward recovery, but consistently toward recovery and actually recovered are separated by a span of time measured in decades, not months. And then there is the quieter dimension underneath all of this, the full ecological inventory of Uluru's surface and the biological communities living in the immediate subsurface environment around the rock's base is not complete. Researchers have noted, in the careful, understated way of people whose professional training makes them reluctant to say anything they cannot fully support, that the site almost certainly contains biological communities and ecological relationships that formal science has not yet fully documented. The climbing ban protected things that nobody had yet identified. Sit with that for a moment. The Anangu asked for the closure on cultural and spiritual grounds that they had articulated clearly for decades, the science arriving later and through a completely different framework, quietly confirmed that the closure was also protecting the rock's ecological integrity, including parts of that integrity that researchers had not yet finished cataloguing. Two entirely different ways of knowing the same place, arriving eventually at the same answer. What is still down there? Here is the honest position on what is currently known and not known about what sits beneath Uluru. The subsurface extent of the rock formation has been mapped with reasonable confidence in its broad outlines. The depth to which the Mutijulu Arkose extends below the surface, the approximate geometry of the formation underground, and its relationship to the surrounding basin geology are all understood at a general level that satisfies most geological purposes. What is not fully understood is the detailed internal structure of the formation, the precise pathways of subsurface water, movement through and around the rock, the full extent of the regional aquifer system that the rock's base interacts with, and the biological communities living in the immediate subsurface environment at the rock's margins. Geophysical surveys of the kind that would provide higher resolution imaging of the subsurface structure require equipment, access arrangements, and research funding that have not always been simultaneously available. The Uluru Kata National Park is jointly managed by the Anangu and Parks Australia, and research conducted within the park is subject to consultation and consent processes that reflect the Anangu's authority over their country. This is as it should be. It also means that certain kinds of survey work simply have not happened yet, not because nobody is interested, but because the research agenda in and around Uluru is not set unilaterally by any single scientific institution. What keeps drawing researchers back is a combination of the rock's genuinely unusual geological character, the ecological significance of the site, and increasingly the recognition that the Anangu's traditional knowledge represents a body of information about this landscape that formal science has barely begun to properly engage with. The Anangu have been watching this rock, living alongside it, and accumulating knowledge about it for somewhere between 50 and 60,000 years. The oldest formal scientific study of the site dates to the 1880s. The gap between those two timelines is not simply a historical curiosity, it is a research resource, an archive of accumulated observation about a specific place, encoded in Chukurpa and in the memories of the community that has held that knowledge continuously, that no instrument currently deployed in the field can replicate or replace. Every time a researcher finds something unexpected beneath Uluru, or in the rock's physical behavior at the surface, there is a reasonable question worth asking. Did the Anangu already know about this? And if so, where in Chukurpa is it encoded? The answer, often enough to matter, is yes, and the work of finding exactly where is still ongoing. Uluru is the most photographed rock on the planet. It appears on refrigerator magnets and airline safety cards, and in the opening frames of more Australian tourism advertisements than any reasonable person could count. It is, in the popular imagination, a known thing, a landmark, a destination with a car park and a visitor centre and a sunset viewing area with a railing. It is also a geological structure of extraordinary complexity sitting atop a subsurface formation that extends to depths still not entirely mapped, made of some of the oldest exposed rock in a continent of ancient rock, operating as a water harvesting system in a desert that should, by rights, have no reliable water, producing sounds in frequency ranges that measurably affect the humans standing near it and surrounded by a body of traditional knowledge accumulated over 60,000 years that formal science is only now seriously beginning to engage with. The rock that everyone thinks they know turns out on every level that actually matters to be considerably stranger and more significant than the photograph on the fridge suggests. That gap between what most people think Uluru is and what it actually is, geologically, ecologically, acoustically, hydrologically, and in terms of the depth of human knowledge accumulated about it, is not a small gap. It is the kind of gap you could lose decades of research into and still not reach the bottom of, which, given what we now know about how deep the rock actually goes, seems like exactly the right metaphor. If this changed how you think about a place most Australians assume they already understand, leave it in the comments and subscribe for more ancient Australian history hiding in plain sight.